All right, so let's practice that one more time quickly before we go on to these word problems. Let me give you an exponential here. This one's not in your notes, just a random exponential. Would you say this guy is increasing or decreasing? Increasing. And we know he's increasing because that number right there, the 1 with the exponent, the number with the exponent is more than 1. What's my y-intercept? I don't know, but I know x is going to be 0. That's how I find the y-intercept. So if I put 0 in there, 2 to the 0th is 1. Times 4 is 4. Plus 1 is 5. So your y-intercept is 5. And where's my horizontal asymptote? Remember, it starts at 0. Always, always, always. But this one has gone up 1. So your horizontal asymptote is at 1. Everybody good with that? All right, let's see what kind of problems we're going to do. The increase in the length of a pumpkin vine can be modeled by this equation. All right, so this tells me how long my pumpkin vine is, and x is in weeks. And it doesn't really say, but down later it says the length is in meters. Okay? So here we go. We're going to answer some questions. What is the initial length? Now, what does that mean? Initial length. The length that it started, and when it started, the very, very beginning, x was what? 0. This is asking you what the y-intercept is. At the very beginning, x is 0. That's when time started. 0 weeks. Very beginning. 0 weeks. So if I put a 0 in there, 1.3 to the 0th is 1. Times 2 is 2. So the answer is 2 meters. How long is it? It's 2 meters when you start. So when you put this vine into the ground, it was 2 meters long already. What is the length after 10 weeks? Now, what does x stand for? The number of weeks. So we're just going to let x be 10. So 2 times 1.3 to the 10th. This isn't like a sequence. This is an actual problem where the variables have meaning. So x is the number of weeks. How long is it after 10 weeks? Well, 27.57 meters. What? That's pretty big. Right? Have you ever seen a pumpkin vine? You've gone pumpkin, right? You know they spread out all over the ground. So that's what's going on here. When will the plant be 12 meters long? When will the plant be 12 meters long? Now, here's my equation for the pumpkin plant. Y is meters, right? That's 12, isn't it? So my equation looks like this. 12 equals 2 times 1.3 to the x. How many weeks does it take for me to get to be 12? Does that make sense to everybody? How do I solve that? Logarithms. But I can't do logarithms until I do what first? Divide by 2. So 6 equals 1.3 to the x. Divide both sides by 2. We always divide first. Then what? Take the log of both sides. So I'll have log 6 equals log 1.3 to the x. What's going to happen to the x? Goes in front. So we'll have log 6 equals x log 1.3. And then we'll simply divide both sides by the log of 1.3. So, are you starting to see that it's a different problem, it's a different application, but don't we do it the same way? Log 6 divided by log 1.3. Looks like it'll be about 6.83 weeks for it to be 12 meters long. You look like you can hardly contain yourselves, all this excitement. All right, now we're going to do the same thing, but we're going to do it for a plant, different kind of plant, has a different equation. So its equation is 1.4, 1.02 to the x. So we're going to ask exactly the same questions, but we're going to be using this equation instead. All right, so what is the initial length? How long is the plant when we get started? 1.4 meters. How did you figure that out? You let x be 0? But if you really think about it, aren't we used to this being our starting number? So it kind of really makes sense that it starts out 1.4. What is the length after 10 weeks? What do we do? Plug in 10 for, which one is the weeks variable? X. So it's going to go in for x. So y will equal 1.4 times 1.02 to the 10 weeks, 10? Did you get 1.71 meters? That doesn't seem like very much. Does that sort of make sense though? What does this number tell us? We're growing, but we're only growing by 2%, so we're not growing very fast. This guy is growing by 30%. All right, when will the plant be 12 meters long? Why don't you try this one on your own with your partner? See if you can figure out when the plant will be 12 meters long. Think about your equation. You gotta solve this equation. Jacob, time to wake up. Come on. We've been rounding off to the nearest hundredth.
Okay.
You got an answer already?
No, I just divided 12 by 1.4.
Oh,
That's what I
oh, okay, yeah. that number, oh, that's a great point, Ellie, thank you. So in solving this, is this the way your equation looks, everyone? All right, in solving this, the first thing you do is divide by 12, or 12 divided by 1.4.
8.57.
And that's, okay, but that is not the answer, is it? I mean, we're not gonna use that as the answer. So let's carry a few more decimal places. Since we're gonna need that number, I'm gonna carry a few more decimal places on that so that I don't have quite so much round off error. Great point, Allie, thank you. Now what? Now we divide. We already divided. Now we take the logarithm. And, okay, let me catch up here. The answer with no round off error at all. So I use my answer button instead of using this. No round off error at all is 108.49 weeks. That's what you got too? Perfect. Are we okay with that? All right, now we're into kind of a tough problem. The rabbit population was 2,000 in 2018, and it was 2,140 in 2019. And we want to know what it will be in 2025. What do you think?
8 to the 6 and then 140. Wait, hold on.
Okay, now you're actually, Sam, you're thinking out loud, and you're thinking kind of along the right lines. Sam's doing something with 140, because what's 140? That's how much it grew by. Oh, can we find the percent? Isn't that really what we need to know? It increases by a certain percent? All right, how would we do that?
By 2,000 by 2140 divided by 2,000.
So 2140 divided by 2,000. Let's type that in on our calculators. That's what Emmett suggested. Let's type that in on our calculators. And see what we get. Oh, that came out to be 1.07, right? Now I heard somebody else say 2,000 divided by 2140. Well, that came out to be 0.9346. Now, which of those seems like the appropriate number to be using in this rabbit population problem? The first one. Why? Because it's increasing. We know that if we use this decimal, our population would not be growing, it would be shrinking, right? So you were exactly right. You knew you needed to divide. You had these two numbers. You can't go wrong. Divide. If your population's growing, it's got to be a number bigger than 1 when you divide, right? So we know we're going to use 1.07. All right? So that's not the answer to the question. We wanna know what is the population in 2025? So help me out. What do you think? What?
I don't know. I think I'm wrong.
Say it. I don't think you're wrong.
2,000.
So we're gonna start with 2,000 because that's our starting population, right? This is our starting population. We're gonna start 2,000 times 1.07. Now, how many years do we have to wait to get from 2000 to 2025? 5 years, right? Or no, I'm sorry. We're going from 2018 to 2025. Sorry. How many years is that? 7. So we want to go 7 years, and that will be the answer to the question. Very, very good. That's a hard problem. And you guys figured it out. Super. 2,000, 1.07 to the 7. Did you get 3211? Actually, 3212. Why am I rounding that off to 3212? Because it's rabbits. It's not money. Most of our problems have been money or feet or inches or something. You can't have a partial rabbit. So we're going to round that off. Okay, one more and then we'll be done for the day. The bunny population was 2,000 in 2018. It was 1910. So let's see, we got 2,000 in 2018, but now we've got 1910 in 2019. What will it be in 2025? So it's the same question basically. But this time, what's our ratio? 1910 divided by 2,000. So it's 0.955. Is everybody okay with that? Is our population going down? Okay. So our answer is going to be 2,000 times 0.955, and again, we're in 7 years. Did you get 1,449 bunnies? I'm impressed. Those are hard problems. Good job. Tomorrow we have our quiz.